In this lesson, we will look at writing molecular, ionic, and net ionic equations for chemical reactions. The type of equations that we're used to writing so far in this course are molecular equations, where we show the reactants and the products. So we should see an arrow here. And we show the states of the reactants and the products. And we also have a balanced equation. So you have experience with writing molecular equations, and for a precipitation reaction where a solid is formed, we're looking at a double displacement reaction. So if we look at this example here, the copper sulfate plus the sodium hydroxide, in a double displacement reaction, the copper joins with the hydroxide to make copper 2 hydroxide, and the sodium makes a compound with sulfate to make sodium sulfate. And you'll notice that the subscripts are used appropriately, and we build our formulas by using the crossover method. We use the solubility rules, which you learned earlier in the year, in order to decide if a substance is soluble in water, which we would list as aqueous, or whether it is a solid or it's insoluble in water. So let's look at this example here. We're taking this reaction, it's taking place in water, and we can use the solubility rules to verify that these two substances are soluble in water. Looking at the solubility rules, number 2 states that any compounds that contain nitrate or NO3- are soluble. So this is aqueous. Rule number 1 states that anything that contains an alkali metal is soluble, so this is also soluble. Now, in order to write the products, the best thing to do is for us to write out the ions that we're dealing with. So by doing the reverse crossover method or by using the periodic table, we can remind ourselves that barium is Ba2+, and nitrate is NO3-. So these are the two ions that make up barium nitrate. For potassium sulfate, when I do the reverse crossover method or refer to the periodic table, I see that I have K+ and SO4 2-. Once I've got these ions written down, it's going to make it easier for me to do all of the other parts of this exercise, and particularly the next step, which is to write the products. So for a double displacement reaction, the barium is going to combine with the sulfate, and with the 2+ and 2- charge, they're in a 1-to-1 ratio, and we make barium sulfate. My second product is made with potassium and nitrate, so in a 1-to-1 ratio, we write KNO3. And remember that the positive ion is always listed first in an ionic compound. Now, referring to the solubility rules, barium sulfate by rule number 4 is insoluble. So when it's insoluble, that means that it forms a solid. Potassium nitrate, which contains an alkali metal, is by rule number 1 soluble, therefore it's dissolved in water. So when we're writing a molecular equation, we need to write the states for each compound, and that's going to be important in the next step. The other thing that I need to do is balance this equation, and I'm going to balance it by putting a 2 in front of the KNO3. So this is my molecular equation for the reaction. All compounds are written in their full form, and their state is properly labeled. And of course, it's a balanced equation. The next reaction that we're going to do is called the ionic equation. When we look at the ionic equation, what it is really focused on zooming in on the beaker to know what's really going on. So before we do an actual reaction, we're going to talk about this, thinking about what's going on in with each of the substances. So let's think about barium nitrate, which we know is soluble in water. We know from earlier on in the year that ionic compounds break up into their ions when they are dissolved in water. So what we want to do is we want to ask ourselves, if barium nitrate, this compound, is broken up, what will we see in the solution? We're going to see barium ions, and we're going to see nitrate ions. And for every one of these, there are going to be 2 nitrate ions. Okay, so you can see I've broken this up, and it's like a little mini balanced equation. The barium, there's 1, and the nitrate, there's 2. So if you were to zoom in on a solution of barium nitrate, what you would see is the barium and the nitrate ions in a 1:2 ratio. For potassium sulfate, it is also aqueous. So when we have a solution of potassium sulfate, what we have are potassium ions and sulfate ions, and they're in a 2:1 ratio. So for every 2 potassiums, there's 1 sulfate. You can see it makes sense. The charge is balanced. Okay, so if I were to zoom in on a solution of potassium sulfate, I would see these ions. Now, if I were to zoom in on my product, so to perform this reaction, what I'm doing is I'm taking the contents of this beaker and I'm adding it to the contents of this beaker. And what we form is barium sulfate solid, which is my precipitate, and potassium nitrate, which is soluble. So the key here is that the barium sulfate, which is a solid, does not break up in the solution. It stays as a solid. So things that are soluble break up into their ions, but things that are not soluble stay together. This here, the potassium nitrate, I have 2 potassium nitrates. 1 potassium nitrate has 1 potassium ion and 1 nitrate ion, but I have 2 of them. So I'm going to write the 4 ions. Now, if we look at this visually, this is actually a balanced equation. I've got 2 potassiums, 2 potassiums, 2 nitrates, 2 nitrates, 1 barium, 1 sulfate. And this is really a visual of what we call our ionic equation. So I'll show you how you write it next. So for an ionic equation, what we need to do is break apart anything that is soluble into its ions. So in the box on your note, you see that the copper sulfate and sodium hydroxide example is listed there. So the copper sulfate was aqueous, so we broke it apart. The sodium hydroxide was aqueous, so we broke it apart. The sodium sulfate was aqueous, so we broke it apart. But the copper hydroxide, which is our solid, stays together. So what we did on the previous slide with the visuals is exactly what we're going to write, but without the beakers. So anything that is aqueous is going to be broken apart into its ions. So barium nitrate breaks up into Ba2 plus 2 nitrates. Here we have 2 potassium ions and 1 sulfate ion. And here the barium sulfate is a solid, so it stays together, and the potassium nitrate is broken up into 2 potassiums and 2 nitrates. And if you look back at the previous screen, this is exactly what we had. We had 1 barium and 2 nitrates. 1 barium and 2 nitrates. We're just writing a little bit differently. So this is called my ionic equation. Sort of a zoomed in version of the reaction where we are visualizing what we would see if we could see at the molecular level. The next equation is the most important equation, and it's called the Net Ionic Equation. And what a net ionic equation does is it allows us to focus on exactly what is happening in the reaction. We can see specifically what chemical change has occurred when this reaction happened. And how we do this is by focusing on what has changed and removing anything that has not. The ions that have remained the same are called spectator ions. Much like when you go to a basketball game and you watch the basketball game, you're called a spectator. So you're not participating in the basketball game, you're just simply there observing. And there are ions that do this in chemical reactions. So let's look at this example here. Just put my arrow here. So in the copper sulfate sodium hydroxide example, if I look at the copper, before it was copper 2+, and now it's part of this ionic compound. So it has changed. It's not in the same state as it was before. The sulfate, however, SO4 2-, is identical before and after the reaction. So this is what we call a spectator ion. It's not changing, it's simply observing the reaction that's occurring. The sodium ions are also spectating. They're both the same before and after. The 2 hydroxide ions are no longer visible. They are part of this precipitate, so they are not spectators. Once you remove the spectators, you're left with the net ionic equation. So copper ions plus the hydroxide ions are producing the copper hydroxide precipitate. That should say solid. And that is our net ionic equation. So I've already written out the ionic equation that you have from our example. And what we want to do is identify the spectator ions. So barium has changed. Nitrate is the same before and after. Potassium is the same before and after. And the sulfate has changed. So my spectators in this case are the potassium and the nitrate ions. And I'm left with barium 2+, which is soluble. If it's an ion, then it's dissolved in water and it's soluble. SO2 is also soluble. And BaSO4 is my solid, so I list it as S. So this is my net ionic equation. There are several practice exercises in your notes that you should do because this takes a lot of practice.